Hello, namaste.
Namaste.
Good morning, everybody. We are having a Vedic Mathematics introduction by eminent experts who have written several books by overseas volunteers for Better India. Before we get into Vedic Mathematics, we will just give a brief background of what OVBI is. You guys can see the slides?
Not
Hello?
yet.
Yes, can you see the slides?
Not
No.
yet.
No.
Okay, can you see it now?
Yes.
Okay. So OBBIA has been started for the last few years by NRIs and also the people in India to to help uplift India. And we have various projects that we have done in India and outside to actually help the Indian diaspora. It was started by Sri Ravi Shankar, where people were asked to give their time, talent, and some money to the nation to volunteer, because we have a lot of problems but when people get together and volunteer, the country can improve. And it is not just up to the government to help out, but we citizens and NRI should also pitch in. And there's a lot of problems in India, like people know about the corruption and all that, but the reason to volunteer is to make India socially vibrant, economically advanced, culturally rooted, where people connect to the heritage and have increase the Indian pride, and also be politically aware. Some of the projects we did around like 1,000 projects. We actually helped 3 or 4 rivers which were dry, and people got together and improved it. And we did it in less money than the government. And so these were some of the other things. We have a lot of volunteers who actually go to 40,000 like villages, and they help out in trying to make them model villages and have sarpanch training, and improve the conditions of all these villages, because a lot of the India lives in the villages. We've also worked with a lot of youths in colleges to actually make them more aware of the country's issues and encourage them to vote. We had like 10 lakh people we registered for voting. And then we have a lot of other projects which we have. And we had a lot of the other things. Was like we had a mobile app where people could actually register to vote. This was very useful. We had a portal where people could actually register. So this is the mobile app where you can easily just put in your details. And this is like on the computer, you can just register yourself to vote, and then some of the volunteers will actually help you. So this, like, thousands of people around the country actually use these applications that we built. And then we also have an educational series going on about the untold history of India. We had a lot of speakers who talked about how India really got independence. Many people don't know the real events that triggered it. And we encourage you to go to these websites, and from Facebook we will share the link how you can access all these past hangouts. And so this is also how NRIs can get together and start a chapter out there and make contacts, and then increase the OVBI memberships. So this is for us NRIs, for us to be more educated, and for us to connect back to what is the real India while we are living in any part of the world. And then this is the website to actually go, and we encourage you to contribute. So now we will ask Mr. Dr. Ramesh to and Mr. Muthuraman ji. They will be actually helping us with the Vedic mathematics part. Yes. Hello. The others can mute if possible. So Mr. Muthuraman ji is a visiting professor of Oxford Engineering College, and he was also the former professor and head of department at Trichy, and also a scientist. His interest has been in Vedic mathematics for many years, and he will actually be guiding us on this. So Muthuraman ji?
Yeah, please.
Yes. So do you want to do your slides?
Yeah, actually we'll go through the planned sequence. We'll have the history, glimpses, and then I'll come to these OER applications.
Okay, so do you want me to drive your slides?
Yeah, Shriram ji.
Okay, so I will actually do your slides then.
Yeah. No,
Yeah.
okay. Actually, we'll be seeing a detailed history a little later, followed by the glimpses, simple illustrative examples through Dr. Shriram and Dr. Ramesh. So, but now I will tell what is the advantage or use of this Vedic mathematics. Actually, if you want to see what is the use, why Vedic mathematics, I want to answer in two broad categories. One is what is the use for we, the human persons, and also it has a lot of use for the computer technology. Computer technology means in turn again coming back to the humans only, doesn't matter. So there is not two parts, it's the same thing, but in the presentation I will put into two groups. So what is the use for human? So in a detailed way, Dr. Shriram and others will be giving later. Yeah. Yeah. So we will go through the slide now.
Okay.
Yeah. So what is the advantage of human? See, we all know this Vedic mathematics is unconventional or very ancient, and it is very simple, very shortcut techniques and faster. It is applicable for both human performing as well as the computer execution. So here for humans, what way it helps is it improves the mental ability, etc.
Slides नहीं दिसते.
Yeah. So it actually Guruji says there are two things very interesting where the mind develops a balanced way, which is very essential for be a good citizen and a good human. So here, these are the things
actually.
Yes. Can everyone hear?
Next.
Go to the next.
Can you speak a little louder, please?
Hear.
Okay, we'll move to the next slide. So actually, I was mentioning that Guruji always tells this our brain. There are two parts, the left and right. The left part normally involves in the monotonous tasks, the worldly affairs, the calculations, logic analysis, like thing. Whereas the right brain, which is creative, involving reasoning, situational understanding, pattern observation, is very rarely used by people. So because of this, what happens normally the mind is not that balanced, which is essential for the holistic development, where one will very wisely do the art of living. We'll go to the next slide. Yeah, these techniques will work not only for the manual method but also for computer, in the sense it's not only for decimal system, for binary hexadecimal also it works well. So very interesting to note, the many papers have been published in high-level conferences where they compare the performance by Vedic method and the classical method, and the results show lesser delay, lower power, lower area, which means the high speed. So in addition to simplicity and flexibility, the VM techniques like Vinculum combo, they yield the best, they expected to yield much better improvement. Actually, the Vinculum we'll be hearing a little later what it is, and it is basically a mixed sign system. So with this, we'll be able to reduce 1 bit. We have to work effectively with 1 bit in the computer. The combo means not only the simple addition, multiplication, etc. We can do the combined operations like the sum of products, product of sums, or any combinations of this. So when we do this in Vedic mathematics, we don't have to arrive at the intermediate solutions. The final solutions can come without getting the intermediate. So obviously a very big advantage comes because of this. So if we can have the architecture ALU, that is the arithmetic logic unit of the CPU, to flow, have the data flow through this way, certainly the much advantages are right. So next slide will go. So this I just mentioned, the combo. Combo is combination, the vinculum is the negative sign systems. We'll move to the next slide. Yeah, so actually what I am imagining, soon we are going to have a EPU. See, now the CPU and the graphics capabilities are added, it was named as GPU. Then further faster CPUs with accelerated capabilities are named APU. Now I am expecting a VPU arrival is not going to be far. So in the sense that the V stands for the Vedic CPU. I already mentioned the execution of the arithmetics. When we go through the Vedic method, a considerable advantage or reduction in time is possible. So if we can have the architecture of the ALU to follow the Vedic method, certainly the VPU will be much faster. Next, please. Yeah, to show where the state of the art in the fabrication of electronics, this is a very good curve. The electronics, people involved in computer electronics, they will automatically know this. This is called the Moore's law. So the earlier founder of the Intel Corporation or so, they have formed a law-like thing. It is not a real physical law, a observation-based law, which says the number of the electronic semiconductor devices that can be put into the given area exponentially increases every year. Or that varies, this is not a law as I told, they go on modifying a little bit. So approximately we can say every year or 18 months how the component increases. So this gives very nice information. The y-axis gives the transistor counts and the x-axis we have the number of years. Unfortunately, we don't have beyond 11 in the open literature. I will give you a little better one a little later. So this we see towards the end, the semiconductor technology itself, people call the pico technology or the nanotechnology. There are various fabrication methods are there. With this, people show advantage over other and all. So included that we see a big cluster there. It's not going beyond that even today. We'll move to the next slide. Yeah, so I told nanotechnology. Here, this graph, the y-axis goes from 10 to 100 nanometers. So this is the, the smallest element, 1 p.m. junction or the CMOS gate. So there are 4 fabrication techniques given in 4 colors. So one is superior over other, that we will not do, but all goes together. So basically, when the dimensions go down, the speed, the power reduces, the speed increases, that type of advantage. So why the speed increases when we go down the size? The inter-electrode capacitances play the major role in delay, the presenting the input and taking the output. That is the real execution time in these gates, and that reduces considerably when the dimension goes down. But we see the 12th month of 2011, the last red dot, that is the lowest dimension they are able to achieve, that is the highest speed 1. And this 10 nanometer means we are very close to the dimensions of the atom or element. So no fabrication technique can go beyond that. Even if it goes beyond that, it is not a semiconductor or computer technology, it will become an atomic explosion, all of you know. We'll continue to the next slide. Yeah, this is a very interesting curve from Intel. The green curve is the Moore's law obedience. That is when the dimension goes down as over the year, how the number of chips in a given relative comparison. That is the green curve. For me, what is very interesting is the thick blue and the pink color ones. So they are respectively for the clock speed and the performance. Performance means the execution time of the computer. So over the period of year, we see in this century, almost beyond 2000, we don't see an improvement. Even though we are able to put more chips into the semiconductor and increase reduce the power or increase the clock speed and all, the performance doesn't show. So this is the right time where the Vedic mathematics application will be really helping us. We'll move to the next. Yeah, Moore's law in semiconductor development I mentioned over years is expected to saturate soon. Since fabrication technology cannot go to the size of an atom, the power speed seems to saturate as we have seen in the Intel curve. We'll move to the next slide. Next slide, please. Yeah. So significant improvement performance in terms of speed, power, and area. Actually, the speed should be higher and the power and area should be lower for better performance. By reconfiguring the logic circuits of the ALU are reported for critical operations like multiplication, etc. The vinculum, the mixed number sign system, the combination of operations like product of sum of products, etc. When we put these additional instructions for the ALU, they will certainly yield a significant improvement. The major area of applications are, in addition to CS pool, the DSP, where the video processing, real-time requirements are finding very difficult even today, which will help you away. And the internet security, the coding, decoding, cryptographic methods, they will help. And in short, I want to mention the day of arrival of a VPU, that is a Vedic processor unit, is not far. So we'll move to the next slide. So I want to conclude by referring to two experts, global experts, well known. So what Einstein told about this is, we owe a lot to the Indians who taught us how to count, without which no worthwhile scientific discovery would have been made. I think this is really a credit to the Vedic ancient Indian system. And let us see what Guruji says in the next slide, the concluding one. If you take science and spirituality together, you will progress in life. And Guruji is supporting a big way the ancient Indian language reaching the globe. So with this, I will make a formal conclusion and we will continue now.
Thank you, Muthuraman ji. That was very helpful.
Oh, thank you.
So now we will actually go to Professor Ramesh, who will. Professor Ramesh, do you want me to go through your slides as well? Can you unmute, Dr. Ramesh? Can you unmute? Yes. Can you hear us? Hello? Dr. Ramesh, can you hear us? Hello? Okay, I think he's having some connectivity problems. The mute button is on the top. There's a panel of buttons on the top.
Okay.
The mute is from the left.
Yeah, I think it's okay.
Hello? Okay, Professor Muthuramanji, do you want to go through his slide?
Hello?
Yeah, I think Dr. Ramesh is coming. Let us see. Yeah.
Hello? I think it is going clear. The voice and all is going clear.
Okay, we are getting.
Okay, so I will go
Hello?
through your slides so you can talk. Yeah. Yes. So I will go through your slides
Hello?
so you can talk.
Yeah, sure.
Yes, we can hear you.
Yeah, sure.
Okay, so I will go through your slides. So
Right.
So I just wanted to introduce Dr. Ramesh. He's a head of Vedic Mathematics department in VVMP Bangalore, Ved Vignan Mahavidyapith institution, and he's the author of several books of mathematics, including Enjoy Vedic Mathematics, and has developed applications which provide personal need through tailored questions. And he has conducted many workshops in premier institutions like IIT and trained many people and taught people from in various regions around the world. So thank you, Mr. Ramesh, for joining us and giving us your time. So I will start your presentation now.
Right.
Yeah, can you all see the slides?
Yeah.
Okay, so you can proceed, Dr. Ramesh. When you every slide you can ask me, I'll go to the next slide.
Yeah. So it's an introduction to Vedic mathematics. In this, basically the Vedic mathematics is in this we carry out the mathematical operations in a simple way, right? So whatever the mathematical operations, whatever the mathematics is there, we can do it very simply based on 16 sutras, and this has been developed by Bharati Bharati Krishna Tirtha. The founder of Vedic mathematics is Bharati Krishna Tirtha. He is 143rd Shankaracharya. He is one of the spiritual masters from India. Next slide. Yeah, how we can make the calculations easy. So this is we do the calculations many times. How we can make it easier? That is most important, right? So when we know the properties, then we can make the calculation simple. That is one thing. And the second thing is the proper guidance, technique, and systematic practice. There are three things are there that are most important. One is the guidance, the proper channel, and the proper technique. And then the most important thing is has to practice. Then only one can achieve these things very easily. And the beautiness of calculations made easy is the way that we are doing is we write whatever the multiplications, divisions, square roots, whatever any calculation is there, we can directly write the answer just in one line, the answer step. So that's how we can make the calculations easy. We can see those things in the few next slides. Next slide. Yeah, suppose this calculation is there. Let us say we have uh, 2518 divided by 39. So when we think of dividing 39, it is really tough, right? So instead of 39, let us say we are taking near the number that is 40. In 40, because anyhow 0 is doesn't play any value, so we'll go and divide with 4. Next click. Yeah. So next click. So we are going to divide with 4 now. So when we are going to divide with 4, we see 4 goes 6 times, and the answer is 4 goes 6 times as 24, and the remainder, next click. And the remainder is 1. So and the next, generally we drop down the 1 here, but instead of 1, what we do is, because we adjusted from 39 to 4, so there is adjustment is there. So with that, one more small adjustment you do further the further calculation. So 1 plus 6 is 7, that we adjust here. So instead of directly 5 plus, instead of directly downing 1, we'll add 1 to 6, the quotient of 6, and then write as 17. Now we'll divide 17 by 4. Next click. So 4 times 4 is 16, and 1 is our remainder. So and then actually we have to drop down 3 and further divide, but because instead of 39 we are taking 4, so we'll take only 3 plus 4, the quotient, last digit of quotient, that is 64, the 4 is there, so that 4 will be added to the 3. So that's how I'm getting 7. So 17. So here my quotient is 64 and remainder is 17. So instead of dividing by 39, just I'm dividing it by 4, and then I get the answer. So that's how, means converting the 39 to 4 is a technique. Once we know the properties of 39, like we can write it as 40 minus 1, and the inside properties of division, how it is multiplying, dividing, and adding that next digit and all. So we can simplify the to simple calculation. Next slide. Next slide, please. Yeah. So here, just for the sake of adding 6 plus 9, generally in our ancient means when I used to learn at smaller age, after 6 it is 7, 8, so on. We count to 9, and then we reached up to 15. So there are different ways to calculation. Like in the bubble, I have shown that it is 6 plus 10 minus 1, that is 16 minus 1 is 15. Or initially we'll subtract 1 and then add 10, where 9 can be written as 10 minus 1 or minus 1 plus 10. So which will become easier. So by knowing the property of 9, which can be written as 10 minus 1 or minus 1 plus 10, we can make it easier, right? So next. Yeah. Yeah. So here let us do the multiplication of 23 by 11. Let us say. So here instead of multiplying, we see that we just drop down the 3. Next, next 2 plus 3 is 5. So we add 2 and 3 and then get 5, and then the last digit is 2. So just by adding and writing the digits, we are getting the multiplication of 11. So exactly the way it is happening, if we see that, then we can do these calculations very easily, right? Next slide. So how one can become an expert in any subject, let us say, means it may be any subject. Again, three things are most important. Again, the idea and knowledge of the topics. So one has to have a clear idea about what topic we are talking, means idea about the topic and knowledge about the topic. And second and most interesting thing is one has to have an interest and passion. So once develop that, then it will become, you can become the expert in that field, whatever field you take of, right? Next click. Next click, please. Yeah. Different ways of doing the same thing, right? This we'll see in the next slides. Next slide. Next click. Yeah. Idea and knowledge. Suppose if you want to just go back one slide, go back.
Yeah.
Yeah, idea and knowledge. So if you want to prepare some whatever dish, if you want to prepare, let us talk about a dish if you want to prepare. So you have to idea about how the dish has to be prepared. You have to have a thorough knowledge of what all the ingredients and all, right? And then next slide. So different ways of preparation. Suppose these things are given to one person, and if you ask me to prepare, I'm not a very good cook. I'm a good mathematician, right? So if you are asking me to prepare this thing, so I'll mix up something and I can prepare only one type of thing. But if you're giving it this to a expert in who is in cooking expert, let us say, they can prepare the same thing, the same contents are same, but they can prepare different things in different ways, right? The same contents will be same, but the output of it is totally different, right? Next slide, please. Next slide. So now I'm going to talk about the basic differences between the Vedic mathematics and the conventional mathematics, the way that we think, right? So how the Vedic mathematics and conventionally whatever we do, how that is different from the Vedic mathematics. So how the Vedic mathematics is different. So in this, the first one is recalling in mind, just like I had, we'll see each and every point with examples. Further slides are examples with all these slides. Just I'm reading out the what all we are going to do further. The getting parts of the answer, the combination of multiple operations, and then recognizing the patterns, that is multiple multiplication. We'll see. Next clicks. Next click. Yeah. Properties of numerals. We'll see some tables, how to write the table, and what are the different. It's not only just arithmetic operations we can use in algebra, trigonometry, and all those things we can be used. And how can we verify the answer? The next click. Next click, please. Yeah. So the operations with different base systems. So octal based system is there. If you're changing the system itself, how we are doing those operations easily using this technique. So the technique will remain same, and then we can use different.
Hello? Hello, Dr. Ramesh, are you there? Dr. Ramesh, can you hear us? I think his internet connection is. Dr. Ramesh? Muthuramanji, do you want to continue from there?
Okay. Yeah, we will.
So sorry about that.
Yeah.
Okay. So can you see the slides?
Yeah, okay, please let us continue. So we will take examples for addition. We'll go to the next slide. So this single digit 3 plus 4, 7, the classical way also, we will move. This is a very simple thing everyone knows. We'll continue. Yeah. So suppose we have got so many numbers, how do we do? We'll go to the next slide. Next slide, please. Yeah. So we take the first two, the top two, and find the result, and we continue. And whenever we get here, what do you call the carry or the 10th place coming, we will put a plus sign in the left hand side. We'll go to the next slide. So finally, when we get 54, so we will put 5 and 4. So how do we get the 5? Because there are 5 carries coming over. We will continue. Next. The same thing we will see. Yeah. So we put a star in Vedic Mathematics. We put the star whenever we get a 7 plus 9, 16. We take 6 and put a star left hand side. We'll go to the next step. We'll add the next 9, and the result will be 5 in the unit place and the star in the left side. Like that, finally, we will be having 4 in the unit place and a star here. So the final result is 4 for the unit place. Since we have 5 red stars, the 10th place assumes number 5. This is how the Vedic mathematics. Now, Dr. Ramesh will continue. Okay. Okay, we'll continue. Yeah. So it is much easier here, and more important, it is error-free for human way of doing. And this, what do you call, the recall or the tabulation is much easier than performing the real calculation, taking the unit digits, 100 digits, etc. We'll continue now. Next slide. Yeah, this I mentioned already. We'll continue. Okay. We'll take the square example, splitting into 2 parts. Okay. Yeah. So we'll take the example of 35 squared. How do we go? We go to the next slide. So we take the left hand side 3, we add 1, n into n plus 1. So 3 into 4 gives 12. That is the left hand side part of the answer. As we mentioned, it's a 2-part answer. The left part answer is we take the 10th place, which is 3, and we add n plus 1 and get 4. The multiplication of 3 times 4 gives 12. So the left part answer is 12. We'll move to the next slide. We'll continue. Yeah, regarding the right part, it is the multiplication of the unit places. We have 35 times 35. So 5 into 5 is the multiplication of the unit places that gives 25. So the answer is 2-part. The left part 12, right part 25. The total answer is 1225. We'll continue to the next example. Yeah, sum and differences of squares. We'll continue. Yeah. So this I mentioned, we don't need the intermediate results for doing these combo operations. This is a good example. We'll continue. So as we mentioned, it's a 2-part answer for squares. So the left part for the 45 squared is 4 into 5. The right part is always 25. So continue, we'll continue. So like that we take all the 3 numbers. So here what we do, we sum up like this, 20 plus 72 minus 90. So this is how this is Dr. Ramesh explained in the first slide. Then since the operation is 2 sums and 1 subtraction, the 20 and 72 goes with the plus sign and the 90 goes with the negative sign. We'll continue for the right part, 3 times 25. So that will be, so this is the answer, 225 is the result. I think anyone has questions, we'll keep it at the end for these things. I think it's very simple. What really we do for squaring is, the left part of the answer is n into n plus 1. For the first number 45, it is 4 into 4 plus 1. The right part of the answer is 5 into 5, pi square. Same thing for 85 and 95. We take care of the sign and we land with number 2 for the left part of the answer. And for the right part of the answer, we have the 25. Okay, we go to the next slide. Multiplication. So this is the general. What we told is the only number ending with 5, like type of things. We will go with a general course. See, Dr. Ramesh mentioned, the expert cook can cook the same ingredients in different way. Now we will see how do we do the next multiplication. Next slide, please. Okay, or before going to next slide, I will explain the pattern. Yeah, you see the 5. Actually, when we have a 3-digit by 3-digit multiplication, the results we should get 5 parts. How do we get this 5 part? 3 plus 3 minus 1. That is m plus n. Suppose we have a m parts in the multiplier and n parts in the multiplicand. The total results will be m plus n minus 1. That is how 3 plus 3 minus 1, 5 parts are there. So the left part is the vertical multiplication. And the right part is the right part multiplication. And the middle part is the cross multiplication and addition. This is a sutra. I think later, I think Shriram ji or someone will explain. For want of time, I will continue. So the 2 cross multiplications and 1 multiplication. And when we take the second part, it is only multiplication of the 2 numbers, cross multiplication of 2 numbers. So fourth part also same thing. But which 2 numbers, which 1 number? The Vedic math is very natural. When you want the left part of the answer, you take the left 2 numbers. When you want the right part, you want the right 2 numbers. In fact, Shriram ji told me sometime back, I remember, this unlike classical maths, this Vedic maths, we can perform any pattern, left to right, left to right, right to left, or middle, any combination we can do. So intentionally I explained the mixed way. We will continue now for an example. How do we do this? Next slide. Yeah, we take the example of 2-digit by 2-digit. So obviously, how many results we should have? Oh, this is a special case. Special case, base multiplication. Oh, this is different method. That other method example has not come. I'm sorry for that. We will continue with the base multiplication. So how do we get the deviation? So we put the number, the 2 numbers. For example, for number 96, we write 96 left hand side. Immediately right side we put 4 bar. This 4 bar, the bar is the vinculum or the negative sign representation. That is nothing but, that is called as deviation in Vedic mathematics. How do we get the deviation? It is shown in the cloud there. 96 minus the number minus base. Suppose for any number, it should be 10 power n form the next immediate number. We should not go 10 power 10, 10 power 12 like that. The immediate 10 power n, that is the base. And when we subtract the number minus base, we get the deviation. So that is how we get the 4 bar. Similarly, for 93, it will be 93 minus 100, it will be minus 7. Okay, we'll continue. Next slide. Yeah, we got minus 7. So how do we get? It's a 2-part answer. The left part is the cross addition. Any cross addition. We can take the bottom or top and do the cross addition. The right part is the product multiplication. So we'll continue and see whether we get the results. Let us continue. Yeah, minus 4, minus 7, when we multiply, we get 28. And similarly, when we cross add 93 minus 4, we get 89. You do the other cross, you will get the same result, interestingly. Okay, we will continue next. Yeah, this is a 3-digit multiplication. This is what that example was showing first. This should have come earlier, doesn't matter. So when we get 201 multiplied by 312, what do we do? The left part of them will continue. We'll go in the same sequence of what Dr. Ramesh planned. Yeah, so we get 6. How do we get 6? The vertical multiplication of the left side. 2 multiply 3, we get 6. And how do we get 2? We take the 2 numbers cross multiply. Which 2 numbers? Vedic maths. Natural, we take the left 2 numbers. So 2, 0, 3, 1, you take and do the cross multiplication. 2 multiplication 1 gives 2, 3 multiplication 0 gives 0. So 2 plus 0 is 0. That is how we get the second digit 2. So we'll go to the third part. We'll continue. Yeah. How do we get 3? 2 cross multiplication and 1 vertical multiplication. So here, since only 3 are there, it's very obvious. So what is the result? 2 multiplied by 2, 3 multiplied plus 3 multiplied by 1 plus 0 multiplied by 1. Effectively 4 plus 3, we get 7. We'll move to the next place. Yeah, here the right 2 numbers, set of numbers we take and do the cross multiplication. 1 into 1 gives 1, 0 into 2 gives 2. That is how the last part, 1 part is number 1. Now what we are seeing is the multiplication for the last part, which is the vertical multiplication of the right 2 numbers. Since it's the right hand side answer, we take the right 2 parts, 1 into 2, 2. So the final result is 62,712. I think it's a very simple thing. Let us see. We'll continue to the next example. Tables. Continue. Yeah, I think we are running short of time. I think I want to hand over to Shriram ji if he is available so that he can tell whatever he wants or he can continue with this.
We can continue. Go on.
Okay. So these integers versus this I have already mentioned. Suppose the decimal system, what is the meaning of decimal system? The number it's a number to the base of 10 actually. When we say 21, the unit digit has got the weightage of 10 power 0. The tens place has got the weightage of 10 power 1. Like that, it goes to any number of places. And 21, we can write as 2 in the tens place and 1 in the unit place. So it is 2 times 10 and 1 times unity. So that is what is the positive numbers we normally have. So vinculum is we can have the mixed sign for any place, different place. See, in our classical method, we either have a negative number or a positive number. But in Vedic mathematics, we have the vinculum system where in the given number, some places can be positive, some places can be negative. Let us continue. Yeah, next click. Yeah, suppose we have a number 2, 1 bar. The 1 bar means negative 1. The 2, the tens place is positive, 1 unit place is negative. Suppose we have a number like 2, 1 bar. What does it mean? The 2 goes with a weightage of 10 as 20, and the 1 bar is obviously minus 1. The value is 19. 20 minus 1 is 19. We'll continue, click and get the result. Yeah, so that is how it goes. Okay, so we'll see, we are moving to the table. Dr. Ramesh ji was mentioning. So it's very simple. For one of time, I will quickly go through. So 20th, 19th table is very difficult. So what we do, we take a 20th table, and what we see, 19 is nothing but 20 minus 1. So what do we do? The first, when we multiply 19 by 1, we get 19, and 19 times 2, what do? We don't have to remember or do the multiplication. Since we are subtracting 1 for one place, when we multiply by 2, what happens? The tens place we subtract by 2, and the unit place we subtract by 1, yielding 38. So like the same thing we continue. 3 becomes 5, 8 becomes 7. When you want to multiply by 3, it goes 76, 95 like that. It's self-explanatory. One can try later. Okay, we'll continue. Yeah, algebraic modeling, pattern reviewing. This we have already mentioned. Is a repetition. We'll continue. Yeah, this is algebra. I think we will skip this for one of time. We'll continue. We'll take the simple cases because I feel we are telling too many things for the first time Vedic math. So we'll continue. Digital root. Yeah, this is very powerful thing. See, in Vedic mathematics, when we perform some mathematical operation, how do we know the result we obtained is correct or not? This is very useful, especially for students community who are missing the centum, 100 marks getting in mathematics. Very bright students do some careless mistakes, with hurry or using wrong memory information. So they can check. So let us see how do we check. So what is the digital root of a number? Digital root of the number is successive addition of all the numbers till we get a unit single place. See, for example, 201, we add 2 plus 0 plus 1, we land with 3. The multiplier is 312. So its digital root is 3 plus 1 plus 2, which is 6. So whatever we are doing the operation, same thing let us do with the digital root. So 3 multiplied by 6 will give 18. And this we have to successively add till we get the single digit. So we get the digital root of the left hand side 9. What about the right hand side? We got the result 62712, which we are interested to verify. So here, what is the digital root of 62712? It gives 18, but we have to further add till we get a single place. So 1 plus 8, 9. So the left hand side also 9, right hand side also 9. So our answer is correct. This is what the digital root verification technique. Let us continue. Yeah, octal numbers. I think this also, for want of time, we will skip. It's not very important. This is a slide and going to be available to everyone. So, okay. Advantages. Yeah, we'll see the advantages. I think the first, initially we saw some advantages quickly. Now we can see more elaborately. It has the speed and accuracy. As we mentioned, these are all very shortcut, or most of the time it is a one-line solution. And we don't not compromising accuracy. See, Dr. Ramesh ji. So presentation, we saw multiple division by 39. Instead of 39, we take 40. Doesn't mean we are losing the accuracy. We are doing the correction, whatever approximation or simplification we are doing. The ill effect we are removing by correction every stage. So we don't suffer any accuracy. So independent verification, just now we saw the digital root method. Optimum utilization of both hemispheres of brain. This also I mentioned initially. The left brain, right brain, both are used. It makes the person a good critical citizen inherently. Unknowingly, one becomes very spiritual. So reflects in other walks of life. Yeah, that's what is the message. Complementary to regular mathematics. See, this is not a different mathematics. As Dr. Ramesh mentioned, your expert cook will do with the same ingredients different things. So we can do. We saw the squaring. How do we do? the special case when the tens digit are same, unit digit is same, tens digit the same unit digits are complementary. How do we do 2 steps instead of 3 steps? So like that, many methods are there for doing the multiplication, for example, and we can choose depending upon the numbers involved. We can choose the method. That is what is the preparation of different food from the same ingredients. So in the classical method, we don't know, we don't have multiplication, only one multiplication. So correlation between different. So this doesn't, there is no difference or discrimination or difference of opinion or differences coming from different branches. They are all like the classical method. There is a integrity with the different branches of mathematics, whether it is trigonometry or whatever it is. Okay, let us continue. Applications. Okay, we'll continue. Yeah, cube root. I think for want of time, I will skip. This is what I feel for introduction for initial people. This is a little more. We will skip this. We will continue. Yeah, let us go to the next slide, please. Yeah, course details. Yeah, actually.
So basically, Muthuraman, sorry to interrupt.
Yeah, please.
The Vedic mathematics aspect, it goes all the way from basic addition to calculus and further. Can you just say a few lines on that?
Yeah, see, like the classical way, we have up to, see, for example, Dr. Ramesh is the doctorate in mathematics. So like that, here also we have different levels in Vedic mathematics in VV, MVP or for any curriculum. So the level 1 contains all arithmetic operations, and it starts with addition, subtraction, multiplication, division, followed by square, square root, cube, cube root, followed by fractions involving LCM, HCM. With all these things is called the level 1 mathematics. So this normally takes year, when a person reaches 12 year, 30 year in Vedic studies, completes this. But who's know already needs only 10 to 12 hours to know in Vedic mathematics. So that is the level 1. Like that, as I mentioned, it goes up to PhD in mathematics. Different levels are there. When we add trigonometry, we add algebra, we add calculus, it's endless. Yeah. I hope it answers you.
Sure, it does.
Okay.
So how different would it be? I guess the most commonsensical question that I'm trying to figure out is that we have calculators nowadays. So you know, if I'm talking to one of the teenagers now, they would just say there's no point to it. Why, I just use the calculator and move on. What kind of answer would you have for something like that?
Yeah, actually, that is not a disadvantage. That's advantage. This advantage, what is claimed, probably not shown in the slides, is the removal of dependency on calculators. That's what in short, if you want the answer. So we need, see, I can tell you very examples. For example, in a country like India, where a group of people are traveling in a private bus for a marriage function or something, 37 people, everybody has to say, pay 67 rupees. How much is the total money you are going to pay? Unless you are accurate, you will be either losing the money to the conductor. If you have Vedic mathematics, one line you can do eventually and take care of the situation. You don't need the calculator there. And in Indian conditions, calculators are not available everywhere.
Right. So it does expand the mental capacity as well.
Exactly.
Right?
Yeah, because intuitively you have to choose the method. Whether you have the Urdu, that is the vertically crosswise method, or as I told, the for a 2 by 2, a 2-part solution method, depending upon the numbers involved. See, for example, the deviation we used, 93 multiplying 97 or something like that, Dr. Ramesh showed. We used the deviation method, so that to calculate that method is not essential to it, but that is applicable in the special case where the numbers are near the base. See, for the numbers 93, 97, the nearest base is 100. So the deviation becomes a small number. You don't have to go to generate a big part answer. See, actually the part answer itself is a shortcut. In that we reduce the parts in case of special cases. For example, when the numbers are near the base, we don't do the classical 3-part answer, we give a 2-part answer. We saw the example 93, 97, 2 numbers. So yeah, here the left-right part activates in the brain and making the holistic development, like the Guruji says.
Okay.
Muthuji, I had a question. Wanted to ask if there are any successful uses of Vedic mathematics in any of the scientific, space, or military, or even commercial, applications.
Yeah, I appreciate it. It's a very, very important question. Actually, my personal interest, I am working a little bit on that. Many people have made a lot of papers showing you take a multiplication Urdhva method, 3 by 3 digit, and when you follow the classical method, what is the delay or the instruction time, execution time, and compare when you take the Vedic route, what is the time, and people have shown the improvement. That is, the time is less. In the VLSI design, people say the area reduces and the power reduces, like all the three important factors make advantages shown. This is a very tiny piece. So when we have to make through so many pieces, we are going to get the ocean. That is what in the introductory talk I was mentioning about the VPU. It is not going to be the CPU, GPU, APU. It is going to be the VPU that will have the lead.
So basically, you're saying that
there are many small, tiny advantages shown by many different people, including Shriram Ji. There are many papers published, but we have to put them together. The combo has not, nobody has done on combo, nobody has used the vinculum. All these things when we put, see the vinculum and combo, they are going to take a leap ahead. So they are going to show a very good improvement factor. I expect minimum factor of 10 or more is very practical.
Mm-hmm. So, are there any examples or any places where there is active research happening at the university level, at the academic level,
no.
In and outside of India?
Not to the best of my knowledge, no. There are many foreigners making these papers based on Vedic mathematics, how the computer time, the architecture, and the logic circuit can be faster. Many papers have come, but they are all, as I told you, a tiny drop of water, so we have to go to the ocean.
Mm-hmm. Thank you, Muthuji.
Thank you.
Thank you. Professor Shriram, are you ready for your slides? Or I can go through your slides and you can talk. Professor Shriram?
Shriramji, please unmute yourself.
The buttons are on the top. Yes. Can you hear us? I think it got muted again. Hello, can you hear us?
Yes, yes.
Okay, thank you. So I will go through your slides and you can talk then, it's okay?
Yes, yes. Yes, please.
So Professor Shriram has also written books about Vedic mathematics, and thank you for your time, and please continue.
Yes.
You can talk. Can you see the slides?
Yes, yes. I can now see the slides. Yes. We continue with the topic on history of Indian mathematics. Next slide, please. We start with what our beloved Guruji says about this. In India, higher and evolved forms of mathematics were in practice since the Vedic times, as well seen through the instances found in the Vedas and related literature. So let us have a quick journey over the period from Vedic period to up to Ramanujam, say. Yes, the scripts which contains the mathematical content are Rigveda, Yajurveda and Atharva Veda, then Yajurveda Samhita, Taittiriya Samhita. Among the Brahmanas, Panchavisha Brahmana and Shatapatha Brahmana contains lot of mathematics. About the Puranas, Agni Puran, Vayu Puran, Narad Puran has lot of mathematics. Shulva Sutras are the parts of the Vedic Samhita. 4 are available, Baudhayana, many of known, Katyayana, Manava and Shulva. Among the Buddha and Jain scripts, there is also a lot of mathematical content available in them, some of which are Lalita Vistara, Surya Pradnyapti, Anuyoga Dvara Sutra, etc. Among the prosody books, Chanda Sutra are the books where lot of mathematical content is available. Next, please. Next, please. Yes, we will go through the timeline of eminent Indian mathematicians, starting from Aryabhata. He is 499 AD, then Varahamira, then Brahmagupta, Sridhara, and Mahavira, having the scripts written Aryabhatiyam, Pancha Siddhantika, Bruhat Samhita, we know it well. Brahmasputa Siddhanta. Sridhara is less known mathematician, but has a very elaborative script called Patiganita, and then comes a Mahavira. This Mahavira is actually different from Jaina Mahavira. He is a different it is not a Tirthankar Mahavira, but a Mahaviracharya, as he said, and he has written the Ganita Sara Sangra in 850 AD. Sridhar and Mahavira are the first Indian mathematician who deviated from the practice of writing subject mathematics as a part of astronomy. They wrote a separate and elaborative book on this topic. Next. Next, please. Next slide, please. Yes. Now, in this talk, I will focus on the Indian contribution, particularly in mathematics. We all know that the number system 1 to 9 and the decimal system, as it is called nowadays, is a gift of India to the world of mathematics, or rather world of science, or the total world itself. Then comes a very important concept, and that is the concept of zero. Zero is a gift of India to the world of mathematics. Just imagine a world where there was no zero. And just imagine that golden moment when one Indian scholar, name not known to the history, has an idea of conceptualizing a zero in mathematics. And that was the very exciting moment of the invention, as you can say it. And then he not only conceptualized the concept on zero, but he has created a symbol for that and put it in a decimal system way. So after 1 to 9, just by writing 0 to the right part of the 1, we get 10. And then it continues up to 99. Then again take a 1, write to 0, we get 100. And that's how the thing goes. Then also, there are binary numeral system available in Chanda Sutra. Floating point numbers are available, and irrational numbers are discussed extensively at the time of period of Shulva Sutra, where root 2 value is calculated correct up to 5 decimal places. They uses it in transforming the square to circle or circle to square. Next, please. Next slide, please. Yes. Then on arithmetic part, 8 basic operations, as the word Ashtaparikarma is used, are widely discussed by almost all the Indian mathematicians. Those 8 operations are addition, subtraction, multiplication, division, square, cube, square root, and cube root. Some Fibonacci-like numbers are also found discussed in Pingala, Chanda Sutra, and in Jain mathematics, we find a use of logarithms type calculations and indices. Rule of indices also find used in Jain mathematics. Next, please. Again, we come to the same idea of the zero, and the zero word itself is derived from the Sanskrit word shunya. Those who know Sanskrit can easily get how from shunya the word travel to please, again, some problem is with the slides here.
Okay, can you see the slides now?
Yes. Again, yes, I can see the slides. The numbers are classified further into even, odd, positive, negative, fractions, rationals, irrationals, surds. The checking methods is one of the important part of this discussion, as we have seen that digital root method to check any operation. It is usually called a Navanka method, or casting of nines from the calculation, and this is done very accurately to verify the calculations of various types of calculations using these checking methods. Next, please. Next slide, please. Yes. There is a very important book called Mainstream of Mathematics. An author is Elizabeth Kramer. He very correctly pointed out this thing. She says, Hindu mathematicians alone of all people included the concept of zero and the symbol zero. And what he's saying about this contribution is 0 is the most civilized of the cardinals, for it represents the greatest degree of abstraction. Next, please. Yes, Aryabhatta is the first Indian mathematician in the whole history of the world mathematics to discover a method of finding a square root and then a method of finding a cube root of a given number. Nowadays, what we taught in the school is nothing but a what we can say is a cosmetic painting of the original Aryabhatta's method. The very important rule, what is called as rule of 3 or Trairashika as it is called in Sanskrit, rule of 3, which is a very important rule in mathematics, very vital rule in all branches of science, rule of 3, is first discovered and applied by Aryabhatta in his book. And by observing the applications of this rule of 3, Western world termed this rule very proudly as the golden rule in mathematics. Next, please. Next slide, please. Yes. Transfinite numbers are numbers that are larger than all finite numbers, yet not necessarily absolutely infinite. Surprisingly, as old as 400 BC, Surya Prajnapti, a Jain script, classifies all transfinite numbers into 3 sets: innumerable, innumerable, and infinite. A very critical definitions are there, but that is not the part of at least today's discussion. Next, please. Now, many people think that beyond numbers, Indian contribution is not there in arithmetic, beyond decimal system or 0 and some operation. But again, that is not the case. A very important part of the arithmetic, which is known as permutations and combinations, and it has wide range of applications in almost all branches of sciences and mathematics. Again, the contribution, original contribution is from India. Mahaviracharya has, for the first time in the history of mathematics, given the formulae for number of combinations of n things selected R at a time, NCR as it is noted.
Professor,
yes, yes.
Just I'm going to, some viewers had some problems seeing the first few slides. So I'm just going to spend a few seconds on the first few slides, okay?
Okay, no problem.
So this is when Shri has also mentioned that these Vedic mathematics was part of earlier times.
Yes, yes.
Then this was the scripts with the mathematical contents, with the Vedas and Puranas. And these were some of the eminent Indian mathematicians that Professor Shriram talked about, right from it's for like thousands of years. Aryabhatta, Brahmagupta, Mahavira. And then these were some more in the last millennium. Bhaskaracharya, Nilakanta. And these are on the right you see the scripts that they've written.
You have moved. Go further. Yes.
And these were some of the other Indian contributions to arithmetic that he talked about. Many times in the textbooks we only see that India invented 0, but there's a lot more the Indians invented in mathematics also, right?
Yes, in arithmetic especially.
Yes, the decimal system and all. Very nice. And these were some more contributions. Fibonacci numbers and indices. It's very interesting to know that we have a very rich contribution to this field.
Yes, yes, that's true.
Aryabhatta calculated pi as well, right?
What?
Aryabhatta.
Yes.
Pi, the value of pi, right?
Yes, yes, yes. But that I kept for the geometry talk.
Okay.
I will have a detailed discussion on value of pi by Indian mathematicians, not only by Aryabhatta but whole lot of many.
So then these were some more contributions about fractions and checking methods, verification methods, and then
This is the comment from that book, Mainstream of
nice,
Mathematics.
nice,
It is a worldwide known book on this.
right, right, and then so besides finding zero, we had a lot of other things like square roots, cube roots.
Finding, yes. We discussed them first for the first time in his history of mathematics.
Very nice. It's
Later on they were what we can say minimized, and some calculations can be minimized.
right, and this is about infinity.
Yes. 3 types of infinite numbers and infinity were discussed by Jain scholars specially.
So this is
Jains
like
were
right. So this is almost like most of the content in the textbooks that we go through in elementary school, middle school, high school. A lot of it is coming from India.
Yes. All basic arithmetic comes from India, originated from India.
Right. And then these were the other contributions.
Yes.
You were on this slide, right? When
Yes.
Please proceed.
Yes. That NCR rule not only for the combinations but for permutations also. The word for permutation used by Bhaskara is Ankapasha, and there is a separate chapter on permutation and combinations in Lilavati. And in the end of the book, Bhaskara tells us that if you want to test anybody's knowledge of mathematics, ask the question from Ankapasha. If he is able to solve those problems, then we can consider that he has sufficient knowledge of mathematics. Next, please. Yes, this is again a very interesting topic of binomial and multinomial expansion. We know the Pascal triangle, word Pascal triangle, but that Pascal triangle word is used in textbook. But before Pascal, there was a Halayudha in the while writing a commentary of Chanda Sutra, describe what is we called a Meru Prastara. The numbers are arranged to give the binomial expansion in the expression a plus b raised to n. Not only the Halayudha, later on Mahavira, Brahmagupta, Bhaskar II, all discuss similar arrangements with the name Khandameru as they are called. And in the end, Narayan Pandit generalized this Halayuda's Meru with the name Sumeru. And I think AOL people will well know the name Sumeru. There are many types Sumeru publications, Sumeru computers, etc. But the word Sumeru in mathematics is related to generalized Khandameru discussed by Narayana Pandit. Yes, next please.
So this we talked about.
Yes, no, and yes, we talked about it. Yes, and the last one now. Again, the slide was shown by Muthuraman. What Einstein has written in his biography, and then say about these things. We owe a lot to Indians who taught us how to count. Means he is acknowledging the contributions of India in the field of arithmetic by saying that without which no worthwhile discovery would have been made. Thank you. Yes, I have finished my. If any questions or anything, I have finished my discussion on this.
Thank you, Professor Shriram.
Yes.
So, do we have any other questions from the audience? You can put on this on the website. I will actually go through this right now.
Shriram, this is Parag. I had a question about integrating all this knowledge or these references in mainstream education. So, since I'm actually reading all these references for the first time. I do not know that some of the very foundational, axioms in mathematics that come from India and Indian mathematicians. How broadly accepted is it amongst the international community, and how is it that if not, that it can be integrated and shared much better with the international community?
The one way is to go through the good books available on history of Indian mathematics. There are a lot of good books available, and then you can read those books. One way is, of course, internet, where you just Google search for Bhaskaracharya or Narayan Pandit or Aryabhatta. But the historical comparison, what was done first in the history of mathematics, needs a comparative study of the literature. That way we can do that. Or you can have any good book on history of mathematics.
Nice.
Shriram, can I also share a list of references or good books that you are mentioning, so we can share them with all the viewers as well as the
yes.
I want to add something for the question as an answer. Actually, recently the central government, Indian government, has assigned with Art of Living organization to induct the Vedic mathematics syllabus into the CBSE. I think it is the work is going on. It is actually it's on an optional basis as an optional subject. The Vedic maths is soon going to be part of CBSE mainstream.
Okay. Long before, actually, in the objectives of that Sarva Shiksha Abhiyan, when they decided the objectives of mathematics, they say that Vedic mathematics should be included as a part of the syllabus. Now, I think it is practically happening, and that's a good news.
Thank you, Shriramji. Thank you, Muthuji.
Yes. Now we will just.
Mehul, could you please talk about the classes that are upcoming?
Yes, I was just about to go there. So, can you see the slides?
Yes.
Okay. All of you can see the slides? Yeah. So we have the classes in Santa Clara, California. And for those who are around here in the San Francisco, San Jose area, we recommend that you come in person, so you can take the full advantage. For the rest of the viewers, the same class will be webcast live. We are charging a small fee to cover the cost, and this will be very interesting. So the first one is about Sanskrit. It is about speaking Sanskrit, and which is also a rich part of our heritage, and very important to know this language. We've had other Google Hangouts. I will give you the link where you can watch the introduction to Sanskrit, and this will be about speaking Sanskrit. So it'll be very nice for us to converse in this the language which is the base of all the other languages. And then this Vedic mathematics, there's a lot to be learned, as we saw from the slides, and basically about how to look at patterns and look at mathematics in a different way, with all the figures and that Professor Ramesh and Professor Muthuraman ji explained to us. So that will be on November 1st, 2nd, 8th and 9th. It will be Saturday and Sunday from 8 to 11 in the morning California time. So people in India, it will be 8:30 in the night. So we hope that people in North America, Europe and many other places are able to watch the live webcast. So this will be like, we'll be doing it in a MOOC style, which is massive open online. So you can also ask questions. We'll have a conference call, like a phone number you can call in, whereas the slides and the video will go on the Google Hangout, but our discussions will go on like a conference call. So this will be a nice use of technology. Now, just going back to OVBI, it is a few Indians that we have got together and started this platform, and then thousands of people have joined in India and around the world, and we've been doing all kinds of projects for NRIs and for people in India. So this is an opportunity for all of you NRIs and Indians, wherever you are, to join on this platform, and then you can also add your projects and your chapters, contribute your time, talent and money, and as Gandhiji said, be the change that you wish to see in the world. It is important for us to increase Indian pride and for us to connect with the heritage and roots in a deeper way, so that a tree is stronger when the roots are deeper. So wherever we come from, in whichever part of the world you are living, as a non-resident Indian from an NRI family, we can learn our heritage and culture better. And some of us actually went all the way to fly to India to vote in the upcoming elections and help out with the voting out there. So this is just one project where we show the commitment of the NRIs, but there's a lot coming. And this is a website where you can go and become a volunteer, find out about events like the one today, and you can donate. And then a lot of current initiatives are happening. That we have something from Sri University. We are actually having a school of good governance. It's important to teach the administrative heads in the villages and towns. So we have 11 scholarships for them. So you can find all about that on our website. And we are here to light a candle to ourselves and to the rest of us, rather than continuing with the darkness. So here is all our events on facebook.com, and we are going to start a new portal soon. But right now all the events are listed here, including the one about Sanskrit, about the real history of India, about how media in India operates. So please view our events, and you're welcome to join any of our projects. So
Mehul, there's another question from the public Hangout.
Yes.
The question is, how would you introduce Vedic mathematics to a child who is 8 years old?
Yes. So Muthuraman ji, you want to take?
Yeah. This actually there is we are talking about level 1, where starting from addition and up to the LCM, HCF it goes, or covering all aspects of arithmetics. Level 0, the last part, that is probably the square root, cube root, and LCM, HCF will not be there. Without that, a slow phase, the same thing can be taught. That's called the level 0. So that is ideal for the people up to age 8, 9.
Okay, thank you. Do we have any? Yeah.
Same way for people who are in college, or people who have finished their regular studies. Do you see any value for them learning Vedic mathematics?
Yeah, especially for those with a computer or electronics background. What I was presenting, basically the same answer to this question. That is how to put these Vedic techniques into the ALU, arithmetic logic unit of the computer, so that we will derive more advantage. It is more important at this juncture, where I was mentioning that even the Moore's law is saturating, and the production techniques cannot go further, because we are already very nearer to the size of the atom or element. Then we will be going atomic engineering rather than computer engineering. So it's the right time. A lot of things has to be done, especially those who are in the computer technology or the electronics engineering. Both the stream will certainly fit into this research work.
All right. Thank you very much. Do any of the panelists, Professor Shriram, Professor Ramesh, you have any other concluding thoughts, comments?
Yes, I will share something. It's very nice to be with you and all the viewers. And I hope by knowing the history of mathematics very correctly, we will be able to have a puff up of our activity in future. So do learn Vedic mathematics. That's what I can say.
Thank you very much. So for viewers, just once more, we will show you the links to register. This is the links to register. tiny.cc .ovbi ES10 is for Sanskrit, and tiny.cc/ovbi ES11 is for Vedic mathematics. The classes are starting on October 11. There are there are limited spots, so please, if you're interested, sign up soon. Whether you are in the Bay Area or you're going to attend the webcast, this will be like a paid event, so you need to register. And the registration is open right now, so please go ahead and take the advantage of that. These things are not offered very regularly, and depending upon which part of the world you are in, webcast might be your only option. So from everyone at overseasvbi.org, I wanted to take this opportunity to thank all the panelists who are here. Professor Muthuraman ji, Professor Ramesh ji, and Professor Shriram. Thank you very much. And also our volunteers. We have the whole Overseas VBI. We have Parag, Vachala, and Krishna out here. So thank you very much for your support. and look forward to seeing you at these classes. In the meantime, you please visit website overseasvbi.org to look at all the upcoming events and initiatives, and to join and to become a volunteer, and spread the word that as NRIs, wherever in the world you are, that we are now together on this one platform, so we can collectively do things for the betterment of NRIs and also the country back, India. Thank you and namaste. Jai Hind.
Namaste. Namaste. Hey, Shuda.